Back today, we're doing problem 167, TwoSum part 2, input array is sorted. So I came across this problem, and the solution is actually pretty straightforward. It's easy, but I think it's a good problem because it utilizes this technique for a lot of array problems, specifically when the input is sorted. I actually think the approach is very similar to another problem called container with most water, which is a different problem that I did in the past, and I'll put a link to that problem and how I did it in the description, but let's get started. So given a one-indexed array of integers that is already sorted in non-decreasing order, I don't know why Leetcode does this, but they should honestly just say like increasing order. At least to me, when I read it, that's what I hear. It wants you to find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where yada yada yada. Return the indices of the two numbers and add 1 as an integer array. So your output, what this is saying is your output is going to be an integer array with two indices that add up to the target, but add 1 to both. That's basically what it's saying. There's exactly one solution, and you may not use the same element twice. For this example, let's read through this one. We're given these numbers here, and our target is 9. The output is 1 and 2. The reason is because 2 and 7 sum up to the number 9, which is the target, but they're index 0 and 1, but we have to add 1, remember what we read up here, to the output for each index, so we output 1 and 2, right? For this problem, we see that second example, 2 and 4 add up to the target, so it's at index 0 and 2, but we add 1, so it's 1 and 3. Same for this example, it's pretty straightforward. So let's talk about the actual approach that we're going to take. What we're going to do is we're going to use a two-pointer approach, one starting from the beginning of the list and one from the end, and we're going to squeeze down until they meet. And the reason we're doing that is we're leveraging the fact that our input is sorted in non-decreasing order. So let's look at this like diagram, right? What we're going to do is, let's say we have a pointer P1, and P1 is going to point here, right? And we have P2, which is our second pointer, and it's going to point here. We're going to take advantage of the fact that the numbers list is already sorted from least to greatest, right? And we're trying to find two numbers that add up to this target. Well, what we're going to do is we're going to sum these two numbers, and let's start that right here. Sum, right? Our sum in this case is 2 plus 15. That is 17. And what we're going to do, right, is 17 is larger than our target. And since we know that it's sorted from least to greatest, we should move our second pointer down. We should move it away from 15, and we should move it to 11. And the reason is because we know that we don't want to have a larger number, a larger sum. We have to decrease our sum to get to the target. So we move from the larger to a smaller number. So our sum is now in the second iteration no longer 17, it's 2 plus 11, it's 13. We see that, hey, this is still the case where it's too large, meaning it's larger than target. And so we move P2 down another time. It's no longer 13, the sum is now 9 because it's 2 plus 7. If the case was that our sum was less than our target, we would move our P1 pointer up. So you're moving in the direction towards the target, right? If it's greater than, move your P2 pointer down. If it's less than, move your P1 pointer up. It's kind of like this sandwich approach. In my head, it's like a sandwich approach. And this is a really common strategy that you can use for other problems as well. It's actually it's what I'm doing in the container with most water problem. The input is not sorted, but you're still going with the same approach for that problem. So let's go ahead and code this up. It's pretty straightforward. So what we're going to do now is let's just create our result, which is an empty list. And P1, P2 is equal to 0, and the length of our numbers minus 1, right? So I have space here. And now what we're going to do is while P1 does not equal P2, the reason I don't do P1 is less than P2 is, remember in this problem, you can't use the same element twice, right? So I don't ever want them to be pointing at the same thing, because if you have a number like 4 as your target, and P1 is at 2, and P2 keeps decrementing because it's too big, they might both point to the same thing, and then it might return the index that the 2 points to at, because 2 plus 2 is equal to the target. So that's why I'm doing while P1 does not equal P2, current sum is equal to numbers at index P1 plus numbers at index P2. Remember what we said before, if current sum is equal to the target, result.append P1 plus 1. And we're going to do the same thing with P2. We're adding 1 because for some reason the problem wants us to increase the indices by 1, where the 2 of them point to some numbers that add up to our target, right? I don't know why they do that. When we're done with this, we're going to break, and then we'll return at the end. If current sum is larger than target, that means that our sum is too large, so we move the pointer that's pointing to the largest number down 1. Else, that means that current sum is less than the target. We move our pointer up 1, the one that's pointing to the smallest value, and we shrink, right? Every iteration we're shrinking down until we get to a target. And at the end, we'll return our result. That should be it. Let me move this over. Great, so that works. Let's talk about the runtime and the memory. So we are, this is an O of N solution in terms of like runtime, because you're just going through the list once, really. You're using 2 pointers. In terms of space complexity, it's O of 1, it's constant. It's just these variables in a result list, but the size of the list is always constant. It's literally just 2 things, right? So that's why it's O of 1. Great.